So here are the half angle identities. So the half angle identities are basically just the reduction identities. But now, so if you look at the reduction identities, we're just applying a square root to all of them. So that's kind of how you get these guys. Now, the one thing about the that's a little different from the reduction identities is that you have this alpha over 2 and then you have this alpha there. Um, don't worry about that so much because if you think about it, you have sine of alpha is equal to plus or minus square root 1 minus cosine of 2 alpha over 2. This is basically what you would do if you just apply a square root to the other ones. But remember that we said that this was double. Okay, so if I were to kind of divide this alpha by 2, then basically what I'm going to get is that this inside is going to be also divided by 2. So all I'm left with is just alpha. So you can see that these two are equivalent. So basically, the half-angle identities are basically the same identities as the reduction identities. It's just that now we just take the square root, and then we have the plus or minus sign, then we have alpha divided by 2. Okay, so it's very, very easy to know. The plus or minus sign depends on where alpha over 2 is. So to know what plus or minus, which one is going to be the plus or minus, we need to find out, we need to find where alpha over 2 is located. So, but I mean the location, I'm saying what is the quadrant where this guy's going to be at. Okay, so these are not very self-explanatory. You notice for tangent, you do have 3 of them. So pick your poison. So first, let's go ahead and just do something that we did with the regular. Sorry, I'm so okay. So what we did kind of like with the sum and difference formulas. So now we want to do with the cosine of 15 degrees. So we know how to find the cosine of 15 degrees. We just took 45 and so we subtracted it from 30 using the sum and difference. But now we want to use the half angle formulas. So we can look at the formula for cosine of alpha over 2. Let's go ahead and write that down. So we have cosine of alpha over 2. That's equal to plus or minus square root 1 plus cosine of alpha over 2. Okay, so that's basically that guy. So what we want to figure out is we want to figure out what exactly cosine of 15 degrees is going to be exactly. So we want to think about what can I divide by 2 to get 15. So, well, that one's kind of pretty simple, right? 30 divided by 2 is going to give me 15. So basically the alpha value in this case should be equal to 30. So that's what I'm going to plug into this formula. Plus or minus square root 1 plus cosine of 30 degrees over 2. So this is going to give me plus or minus square root 1 plus, so now the cosine of 30 degrees is going to be equal to square root of 3 over 2 divided by 2. And then I'm going to get plus or minus square root. All right, so this is just going to be a 2 over 2 plus square root of 3 over 2 over 2. So the top part is going to be 2 plus square root of 3 over 2, and then all of this is divided by 2. It's going to give me plus or minus square root 2 plus square root of 3 over 4. Okay. You can always continue reducing it and just write plus or minus. So the top part is going to be square rooted. So you have a square root of 2 plus the square root of 3 divided by 2 because the square root of 4 is going to be a 2. Now, which one is it? Is it positive or negative? Well, if we look at 15 degrees, 15 degrees is in quadrant 1. And in quadrant 1, all of them are positive. So we're going to choose a positive one. So it's going to be, whoops, the positive square root of 2 plus square root of 3 divided by 2. That's going to be the answer. Okay, so we can also figure out what the exact value of it is going to be using the half angle identities. Okay, so now let's do this other problem. Okay, so here what we want to figure out is suppose that cosecant of x is equal to 7 and x is in quadrant 2. So we want to find all the half-angle identities for sine, cosine, and tangent. All right, so first let's think about where cosecant is at. We know that x is in quadrant 2. Okay, so it's going to be in quadrant 2. So we're going to draw our triangle right here. Here is x. Now, if we think about cosecant, cosecant is the opposite of sine. And then if you think of sine, sine is going to be the opposite over the hypotenuse, which means that the cosecant is going to be the hypotenuse over the opposite. So in this case, it's going to be 7 over 1. Okay, so that's going to be the cosecant. Now we got to figure out this bottom part. Okay, so using Pythagorean identity, we're going to get a squared plus 1 squared equals 7 squared. So a squared plus 1 equals 49. Subtract the 1, so it gets square root of 48. You can actually try to reduce this. So if you go into your calculator and put square root of 48, you will see that I'm going to get 4 square root of 3. So you want to make it a little nicer. Now, you have to be very careful because this is plus or minus. Is this going to be a positive or a negative? Well, in quadrant 2, the sign is positive. Okay, so we know that those are positive, but we know that this is in the negative x-axis, so this should be negative. Negative 4 square root of 3. So this guy should be a negative. Okay. All right, now that we have basically everything, all we got to do is now figure out what's going to be the sine of x over 2. So let's start off by writing down the formula. So let's go back up, look at the formula for sine of alpha over 2. That's just going to be plus or minus square root of 1 minus the cosine of x, in this case, divided by 2. So we're going to write plus or minus the square root of 1 minus the cosine. The cosine in this case is going to be the adjacent over the hypotenuse. That's going to be negative 4 square root of 3 over 7 divided by 2. So this is plus or minus square root 1 plus 4 square root of 3 over 7 divided by 2. Okay, so on the top part, I'm going to get 7 over 7 plus 4 square root of 3 over 7 over 2. Oh, wait a minute. Why am I changing it to a name? Oh, yeah. Okay. Got it. Okay. So plus or minus square root. So you're going to get 7 plus 4 square root of 3 divided by 7 divided by 2. So then I get plus or minus square root of 7 plus 4 square root of 3 divided by 14. Okay. Alrighty, so you can leave it like this. You can reduce it even more if you want to. Now, the only thing that's really difficult is that you need to figure out where exactly x over 2 is going to be at. Now, we're going to do something that we were doing in the previous one, which was with a double angle. We're trying to figure out where 2 theta was. Well, in this case, we know where x is. X in this case is between pi over 2 and pi, which basically means it's in quadrant 2. So if I want to know where x over 2 is, well, all I got to do is divide everything by 2. So this is going to give me pi over 4, and it's going to give me pi over 2. Which means this guy, this x over 2, is between 45 degrees and 90 degrees, which is in quadrant 1. So that tells me that this x over 2 is here in quadrant 1. And in quadrant 1, everyone is positive. So this guy is going to be a positive. Okay, so we're going to leave it as is. Okay, now let's go ahead and figure out what cosine of x over 2 is. Now that we know that x over 2 is going to be positive. So we're just going to choose a positive one because we already know that it's going to be positive. Square root of 1 plus cosine of x over 2. All right. So this is going to give me the square root of 1 plus cosine. In this case, we already know what that was. That was this negative 4 square root of 3 over 2. Oh no, square root of 3 over 7 divided by 2. So this is going to be 7 over 7 minus 4 square root of 3 over 7 divided by 2. And this is going to give me the square root of 7 minus 4 square root of 3 over 7 divided by 2, which gives me the square root of 7 minus 4 square root of 3 divided by 14. Okay, so this will be my final answer for cosine of x over 2. Finally, we're just going to use the tangent of x over 2. Now, the tangent of x over 2, we can just look at this last formula. Okay, so it's going to be plus or minus, which we know is plus. Sorry, plus or minus. So you're going to have 1 minus cosine of x, 1 plus cosine of x. Okay, so that was basically the formula for tangent of x over 2, which is just this guy. Now we know that the tangent is going to be positive because it's in quadrant 1. So it's positive, so it's going to stay positive. So we're going to be 1 over the cosine of x, which we knew what that was. That was just negative 4 square root of 3 over 7. And then 1 plus negative 4 square root of 7 over 7. Oh, square root of 3. Okay, and at this point, I think this should be really good. You don't need to, I mean, you can if you really want to, but I feel like there's going to be a point where the tangent gets a little bit messy, and I will accept this. This will be fine. Okay, so same thing that we've been doing. The only thing that was probably a little subtle was trying to figure out where exactly this x over 2 was at. But doing a little bit of algebra, very similar to how we were graphing it, is basically all we really need to solve these problems.